Hey everyone, today we're going to look at how to create an exercise for V3. We're going to be looking at how to create the first Ruby exercise, the basics exercise, and I'm going to be porting it from the C# exercise that's already done. I'm just going to be talking through the sort of mental process I'd go through in copying an exercise over and thinking about it, and some of the practical things that need to happen as well. And this is primarily going to be a screencast. I'm going to be showing you my screen, going to just be working in Vim, and so you can just watch along and then fire any questions at me in the comments below afterwards. Let's get started. So the first thing you need is to get the actual V3 repository pulled down onto your machine. It lives on Github at Exercism V3. So if you navigate there, then go to clone or download, grab this snippet, and then go to your console and git clone it. That'll pull it down. Should take no more than a couple of seconds, and that puts it into a folder somewhere. So we're going to go into Vim. I've already got it here. We can have a look at it. And we're specifically looking into the languages directory. I'm looking into the Ruby one today, and into exercises and concepts. And you can see currently there's a strings exercise in here. I'm going to add a new exercise called basics. So we're going to base this exercise on the C# equivalent. So the first thing to do is go and have a look at that. I'm going to go to GitHub and have a look at it there because it's actually currently still a pull request rather than having been merged. It's this one here. So if we go and have a little look at that, there's a whole load of files in here that we don't need to worry about too much for now. The ones that matter are the introduction, the instructions, then the stub, and an example. So let's just quickly talk through these and just have a reminder of what each of these things are. So firstly, we have the introduction. The introduction aims to explain enough about the concept that somebody understands the basics of it and have enough mental map that they're able to work out how they would Google for it, how they would look for more information. So if we look at the one here, we're talking in this example about C#, explain that it's a statically typed language, and explaining what that means. Just explaining the term variable, which is probably very familiar to most people, but you might come from some languages where things are not called variables. And we provide a little example of that and the two different ways that you can define that in C# that are relatively equivalent. And then we explain that you update variables by using the equals operator. Again, this might feel super familiar to you, but actually a lot of languages use different operators to update to the ones that they initially set values to. So it's quite important to explain that. And also, because C# is an object-oriented language, we require things to be put in classes. And so we need to explain about classes. So this, without going into more detail, as you can see, is just an introduction to the fundamental things in C# that you need to know, and the introduction is acting as something just to give enough information and then let somebody be able to Google around. We're not explaining what object-oriented means. If you want to know more about that, we've put a link at the bottom that people can follow to go and do that. This one's a Microsoft link. Eventually we might write our own docs for this sort of thing. That's sort of on the roadmap. But for now, either just linking to external docs like Eric's done here, or linking to the reference folder, and then later on we're going to do a massive pass through. Anything that links back into our reference folder, we're going to extract those things and actually write user-facing docs for. So that's another option now, as long as you're happy to contribute to writing the docs later on. So introduction, explain a concept, give someone enough mental scaffolding that they can go and they can start Googling around that thing. Then we have the introduction. The instructions. So the instructions are. So then we have the instructions. The instructions are about the exercise. Exercises normally have some sort of story or theme or idea. This one is about cooking a lasagna. The instructions should break down very clearly the tasks that you're expected to do, and they should give samples of the code that is going to be run for each of them. Now ideally, and this is probably not true in this case, but ideally the samples that are given shouldn't be the same as what are in the tests. We're actually intending to make these code samples runnable for people later on. So you can probably in the UI have a button here that you could click on and it would run that as if it was a test, so that you can go through and you can try and implement the various pieces in here. But we want the actual test suite to be testing different things to the things that the person's told in the first place. So just a general piece of advice there. But The instructions split into these 4 different categories for this one, because there are 4 different methods that we're asking someone to do. And we want to be quite specific that you're supposed to define this method that does this and does this, or define this one that does this or does this. And the final thing I want to look at to start with is the example file. So I think this is, when writing exercises, probably the best place to start. Come up with an example of what sort of vaguely the idea in your head looks like. So for this example, it's a lasagna with 4 methods. It's really simple, as you can see. The aim of this is just to get people familiar with the syntax. But actually, I think by writing out a solution that uses the concepts you're trying to explain, that really helps you frame in your mind what it is that you're trying to teach, what the prerequisites of this exercise might be, and makes you think about how you can simplify it, whether that feels like a solution that's going to take 5 minutes for someone that's experienced, but a little longer for someone that's not, whether it's too simple, whether it's too complex. And it's important to remember as well that people are coming from very different backgrounds. So in this scenario, I mean, this is like an absolutely trivial piece of code for somebody that's an experienced programmer with object-oriented code. Like, it's a very basic class, very basic functions. You might not quite get the syntax, the sort of fat arrow syntax rather than brackets and things might feel a bit alien to people, but you'd probably get it quite quickly. If you've never used object-oriented programming before, then someone's going to spend 20, 30 minutes, hours, working out what a class is, what the difference between a method and a function is. So it's important to remember that although it might feel really trivial for you, you've got so much knowledge in your head about these things that even very experienced programmers who have come from totally different paradigms might have a huge amount to learn. So Eric's decided, and I agree, that in this case, having 4 very simple functions that show a couple of basic mathematical operators that show how to return something from a function implicitly in this case, and how to define classes and methods is the most sensible way forward. I'm going to make slightly different decisions, I think, when I make this in Ruby in a second. But yeah, we'll take that journey together. So let's get started moving this to Ruby. So I'm going to go back into Vim. First of all, I'm just going to jump into this concept exercise directory. Just so it clears the tree up a little bit. And I'm going to make a directory here. I'm going to do exactly what Eric's done and call that basics. So we need to put some of the files in that Eric's got here. So you'll notice that the example lives in a meta directory. So let's cd into basics. And let's make a new directory in here called meta. And then let's open up a file called meta. And then we're going to use example .rb. So I'm going to take this code directly from here and paste it into this file. I'm pretty confident that my end solution is going to look relatively similar to this. So I'm happy just to go and turn this from C# into Ruby. I won't make you sit and watch that. I'll fast forward for you. Cool. So I've turned that into Ruby. It's exactly the same code in terms of functionality. It's now just Ruby rather than C#. So let's actually look at what this code's doing, because we've sort of jumped over that so far. So best place to do that is actually to go and just read the instructions. So there are 4 tasks, all related to time spent cooking the lasagna. So first is to define the expected oven time in minutes. And so Eric's got this as a method, expected minutes, 40 minutes. And we're just getting that as a constant. According to the cooking book, the expected time in minutes is 40. So there's a question here about whether this should be a constant. That's a decision to make. Let's come back to that in a second. But the second one, calculate the remaining time in minutes. So this takes the actual amount of time it's been in there so far and sees how long is left based on this expected minutes. So I mean, this is very basic arithmetic, but this is now having a method that's taking a parameter, which is something you want to show, and then showing that you can do basic arithmetic between 2 things. Next is the preparation time in minutes. So define the preparation time that takes the amount of layers you're going to add and returns how many minutes you spend preparing it. And we're presuming that each minute takes 2 minutes. So again, we just got a 2 here. Again, my gut instinct says, this is a good time to introduce a constant. So we'll think about that, but we've got 2 potential uses of constants here now, so maybe that's a good thing to do. And then finally is the calculate the total working time in minutes. So this is basically just adding up the preparation time. It's a typo that I've made. The preparation time here, and then the actual minutes in the oven so far. So this is showing how you call another method. So that's pretty basic. I'm quite happy with that. I think the biggest question here is, should we be using constants instead of just sort of this magic number here and a method that just returns constant value there? And thinking about the scope of the exercise, I'm going to say yes, I think we should. So in Ruby, we have a general convention that we put things in block capitals. Oh, I have cap logs on. That's going to really confuse them. We have a general convention that we put things in block capitals like this if they're constants. So let's do that. And then let's say we have a preparation, what should we call this? Preparation minutes per layer. And that will be 2. And then we're going to say, let's sub this out here. Cool, that feels a bit cleaner to me. So what else might we want to teach here? Is this pretty good for a basic exercise? So the other thing that jumps out to me is that we're teaching one method here of calling a method just by passing a parameter in. But actually in Ruby now we have named parameters, which look something like this. So I think it would be nice to teach both styles of that in this first example, because we're defining the fact that this is going to get called, this total time in minutes. We can make it quite clear how they're supposed to use it. And I think that is a good thing to be teaching straight away to allow us to use that later on. So I think those are the 2 changes. We're going to have to teach people how to use classes, which is going to be a link out to object-oriented documentation. We're defining how to use methods and the fact that they implicitly return. We've got constants in here, and we've got the other type of method definitions that looks like this. So that's definitely as much as I would want to introduce in this exercise. I would take the argument that introducing constants is maybe a step too far. I think I'm going to go for it. I might get ruled down in code review. I'll have that debate with people there. But I think it's probably enough. I think this is a good way to start your exercises when you're porting things over. So take the code that feels good to you, take that basic setup and say, does this feel like I'm introducing too many things? Is the exercise too simple or too trivial? Working that out, then I think from that stage you can then write the instructions. Obviously a lot of the work's been done here because I'm porting this directly from what Eric's already done in the C# exercise. But even if I was just making a new exercise, and I'll do another video on making an exercise from scratch, this would still be the approach I'd take. I'd come up with a story in my head. I'd just sort of hack around with some code. I'd probably write a test file that sits next to it and just run that code a few times, see what feels good. And then once I've got that, that's the stage that I would then think about, okay, what are the prerequisites? What are the formal concepts I'm teaching? What's the introduction? What's the instructions? All of that to me comes out of code because code is how we're thinking. It's what we're trying to teach. This is the lesson. Only when we know what we're trying to teach can we then go and explain it and work everything else out. And I think there's an instinct to go and write the instructions first and the introduction first. I mean, that's a lot harder because as developers, this is what we're used to. It's code. It makes sense to us. We get a feel for it. We understand the complexity. If you ever taught anyone in the real world, you understand which parts of this feel good or bad to teach. So I would always start with code. So next, let's look at instructions. So again, I'm just going to take all of this. I'm going to go this way. I'm not. Let's go there. So let's just take in, how do I spell instructions? Okay, so these are the instructions. I'm just taking them straight from C#. And let's just make myself some space here. So let's go through this file. We need to turn it from C# examples into Ruby examples. And we need to specifically update these expected minutes in the oven constant up here, and then down here explicitly use these parameters that we're going to use. Okay, so I've updated all of these now so that they actually correspond to the code we've got here. We've got our constant, we've got our remaining time in the oven, our preparation time in minutes, and then at the bottom here we've got our example, which has two parameters, which uses name parameters instead. So these instructions have been updated, pretty simple, pretty quick, took 2 minutes to do. We're done. So next we're going to look at the introduction, and if you remember earlier I explained that the introduction explains the concept and the mental framework you need to use it. So I'm going to grab this and grab the raw, and let's have a look at introduction.md. So this is the bit that's probably going to be where you spend most of your time thinking and getting it right. It's probably the more complicated bit. Because this is where you need to try and work out exactly what you're going to say to somebody to get through to them in a language that they understand, depending on the whole wide range of backgrounds they might have. So I'm not going to update this live, but I'm going to talk through what I would do as I was thinking through it, and then I'll show you what I've come up with afterwards. So this example starts by explaining that C# is a statically typed language. So it explains what types are, it explains what variables are, it shows how to set them and how to update them. So that's pretty similar to what we can do for Ruby. We can explain that Ruby is the opposite, it's a dynamic language. And I'd like to explain that things can be constants or variables. Constants are defined with capital letters, variables are defined with small initial letters. And a similar thing to say that they can be set or updated using the equal sign. So the first thing I'll do is update that. Okay, so I've rewritten the first part of this. I'm saying Ruby is a dynamic object-oriented language. Everything in Ruby is an object, and then I explain that you can assign either variables or constants, a little bit about how variables work and the fact that they can just be arbitrarily reassigned, and the fact that constants can only be assigned once, and then this is not allowed. I'll put this in as a first pass. We can get some code review. People can suggest how I can make it a little bit better. But I think that does the job as an introduction. So I'm now going to go and do the same for the rest of this file. It talks about how you've got classes that have got functions defined in them, what that looks like, how you call those functions, etc. He also mentions about comments so that they're familiar when someone reads code. So I'll go away and update all of this, and then we can have a look in a minute. Okay, so I've got my final first cut of this now. I've talked a little bit about how Ruby's organized into classes. I've explained how you would write and initialize a class, and then I've explained that functions are known as methods because they're defined within classes. And I've looked at the different ways that you can define methods with unnamed parameters, or named parameters. I'm not sure if unnamed parameters is the right syntax. Somebody can pick that up in code review. And also explained about how you can call methods using the dot syntax. So I think that's probably a good enough first pass. When we put it all together, we'll see whether it fits or not. But that's sort of the methodology I'd use. What are the things that we're showing in here? Make sure they're all explained in here. one thing I want to talk about a little bit is this use of code samples. So ideally, we don't want to show much code in here because we don't want to just give things away. We don't want the exercises just to become Lego puzzles by picking and pulling parts from the introduction and sticking them together. What we want is for somebody to be able to look at this and get some understanding, but then still have to use their brain to think about what this actual code looks like. So for this, I'm sort of okay with it because although we are probably a bit similar having a calculator, and maybe I'll think of a different way to do this, it's not a calculator, so it's even more dissimilar. The fact that we're sort of calling methods here within a class, the fact that we're using either constants or magic numbers and things, it feels different enough to this example that somebody's still going to have to think to be able to try and map what they're reading here over into that code. If this was using any of the same sort of examples, lasagna for example, in here, that would be wrong. We wouldn't want to make it that simple or that easy for people. So the general rule we're using for this, and with a lot of this stuff, it's sort of, there's a lot of judgment calls in there. But the general rule is that we don't want someone to have to go and Google syntax. We want to be able to tell them the syntax and explain syntax to them within the introduction file. Whereas for, I guess, what I've been calling skills, for lack of a better word, so looking at all the different methods on a string if you're trying to work out how to do string manipulation or things like that, I wouldn't just want to list the methods that someone needs to use in introduction. I'd want to give them a link out to the docs so they can read it for themselves. Because a big part of learning a programming language is being able to know how to Google for those terms, how to think about those things. And if we take all that away and just spoon feed them, they're not going to be learning anything. So general rule of thumb, explain syntax by giving examples of what it looks like in code. But don't just tell people methods, don't just tell people solutions. Let them work that stuff out for themselves. Okay, so we've got our introduction, we've got our instructions, we've got our exercise example solution. So there are four more things to do. There's the stub of the actual exercise, which is really quick and easy. We'll look at that. There's the test file, and then there's the after and the hints markdown files. There's then some other config files around that, but I'm not too worried about that for this video. So let's just talk for now about those things. So let's have a look over here. So let's start with Eric's example for C# for the stub file. So let's add the file here. We're going to call it, what's it called? It basics. Yeah, so we'll call it basics .rb. So this is Eric's. So let's just change these to be Ruby comments to start with. We can delete that and we can delete that. So the question is, do we do this where we define the class with the methods inside, or do we not? I am really split between these two things. I think there's something quite nice about having the class. I think we're going to have the class because I want to make it clear that you define the expected minutes in oven constant here. And I don't think we've necessarily made it really clear that you would define that within the class in our instructions. So I think putting the class here and then explain to somebody to do that is a nicer way of doing it than writing more text into the actual instructions. So let's just change this, remaining minutes in oven, prep, I can never spell this word, time in minutes, and total time in minutes. I really need a nice shortcut in Vim that just takes camel case to snake case. If anyone wants to send me a link to a good one of those, that'd be great. So I think that's the stub. I'm quite pleased with that. I think it's really simple, really easy. Nothing else really needs to get done with that. So yeah, job done. So next we've got the tests. Let's take a look at Eric's tests. So let's pull this in again. Let's call this basics test.rb. I have no idea what the syntax looks like for the other Ruby exercises. Let's just take a little look on here and see how tests have been done so we can be consistent. Exercises, concept, strings, and then the log parsing test. Okay, cool. So making sure that things are consistent is really important in this. And if somebody's already done something a certain way, then I think it's important to respect that. If you disagree with what they've done, that's obviously totally reasonable. But I think that needs to be a conversation that's had about updating all of the old exercises, not just putting a random different thing in here. So let's change this to be basics, and I'm going to change this. So this is actually called lasagna, and I'm going to change the file name of the other one to be lasagna 2. It's a really hard word to spell. And change this file name to be lasagna test. So we're consistent. So we can just check over here. We now have lasagna test. Both of those, are they in the right place or should they be in meta? I can't remember. They should be in docs. Cool. So let's move those in a bit, but we can just remember for now to put those in the wrong places. So we can then just basically copy the tests of C#. So this would be lasagna, expected minutes in oven, etc. And we can just rename this to be correct, expected. So there's a whole extra thing I could do here about how test runners should work to work with the new in-browser coding. I recommend looking at how the research website and the research project is set up if you want to understand more about how that will work, rules around this. I think there's probably another video in there to discuss that and explore that a little bit. So let's not go into too much detail. I'm just going to quickly reproduce all of those tests and I'll be back in a sec. Okay, so we've now got some tests. I haven't actually tried them. I will of course do that before I put the pull request up, but that's a test suite that looks pretty straightforward. It's exactly copied from C# and just transposed over. The only real change is this being a constant and this having named parameters in it. So that's done. Again, really simple. Once you've done the example file in the first place, writing the tests for it, especially if you're just porting those over like this, should be a pretty straightforward thing to do. So that's good. We've got our stub, we've got our test file, our instructions, our introduction. So that's everything that somebody would get to solve the exercise. So all of that together should be a nice solvable unit of work. So the final two things now are the hints and the after file. So let's start off with the hints. So the hints file is there for if somebody gets stuck throughout the exercise. We're aiming so that the hints will actually live by each of the sections within the instructions. So for example, there'll be a hint button next to the instructions. You press that and you'll get these hints here. For the second one, which is on the remaining time in the oven, there'll be a hint button. You press that and you'll get these little tips here. So we're probably going to reformat these later on. We're not too worried exactly about getting that format right now. So again, just keep it consistent in your track to make it easy to change later. And we can define that slightly more towards the end of the whole thing. So an integer value you can define as one or more consecutive digits. That makes sense as a general hint. So this is a hint if somebody is confused about how to define an integer. I mean, they've seen it in the example in the introduction. So they shouldn't get stuck, but maybe they do. So define the expected oven time in minutes. Now obviously this is quite different. So rather than defining a method, we're going to say we need to define a constant. We don't need to say any arguments. And should contain the value specified in the recipe. Let's bring that story back into the case. And say the integer value. Cool. So So I'm going to do that as again for the rest of them, and then you can have a look in a second. Cool. So this file's now done. I found a whole load of resources down here at the bottom that I thought were useful. This is a good basic hints file. If someone gets stuck, they can pop this up, they can look at more things. I think we're sorted. So the final thing to look at then is the after. The after file, this is going to be really important. We're still working out exactly what we're going to do with this, but we're thinking this is going to become the base class, the base file that somebody can use to make their own sets of notes on things. So we're thinking of this as a really nice extensible document. We'll give them this and they can then go and extend it themselves, make their own notes, add things to it, almost like building a personal wiki of knowledge. The aim here is to go into more depth than in the introduction. So the introduction, again, that's pretty much exactly what it said in the introduction, but there's a lot more detail going into all of these things. We've got things like the static keyword coming in, which we didn't have earlier. Things like this that we don't need to show to get someone to that very first thing, but we do want to put in their mind. And one of the things that we're saying is when somebody's completed this exercise, we're expecting them not only to know the things they've coded, but also have some knowledge of the things in this after file. So if Eric here has mentioned the static keyword, then we're quite comfortable using the static keyword in the next exercise that has this as a prerequisite, even though someone hasn't used it before. Because it's only quite a small thing, we don't need a whole exercise on static. It's not worth it in C#. Something to consider is that this after file can add a bit more detail than you've used in the actual exercise. But again, there's a very thin line there between suddenly just telling someone like giving them a textbook and it not actually sinking in. But we're going to make it really easy for people to jump back to these after files when they're doing other things. We might well have a list of the prerequisites that show up, and then you can quickly jump to those files from those after files from the prerequisites, so you can go and look at them. So I think this is a really important file just to get right, to put some time, some effort, some thought into. It's also something that I'd say that is something that you can almost come back to. I'd be quite happy right now for the PRs, the pull requests with these exercises to just have very basic after.md files and for us to flesh these out later. I think these shouldn't stop us from quickly moving forward, because these are the sort of things you want to spend time on, you want to refine. And at the stage we're at right now, getting a good handful of exercises in, I think is a better starting place than trying to perfect these files in depth. So I'm not going to do that right now, just so I can get this video out a bit quicker without spending the time on doing that. But I think that's the fundamentals that you need to know about porting an exercise over from one language to another. Always start with that example. That's my number one piece of advice. Once you've got the example, think about the introduction. What are the concepts that you're trying to introduce? Just look at that example, look at everything that's in there and make sure that everything in there is referenced either in that introduction or that it's referenced in another exercise somewhere before this. Or of course, just tell yourself this is going to be referenced in another exercise before it, and then make a concept exercise issue saying we need a concept exercise that's going to cover this topic. That's a perfectly acceptable way of doing it too. Once you've got that example and you've got those introductions, and those two things fit together and they feel sane and the introduction feels quite short still, then you can just work out the instructions. That should be pretty straightforward. That's just telling the story around the example. Then you can throw the stub in there, and the stub is everything that's not boilerplate, with gets commented so it's clear what needs to happen, with a bit of boilerplate for anything that we don't want to have to introduce the student to at this stage. Then we've got the tests that actually refer to that. Again, they should be really simple. They should just make sure someone's pushed in the direction you want them to go into, and then we follow that up with the hints and with the after file. I'm not going to talk here about how we actually do the pull requests. If you need help with that, you can message on Slack and somebody will help with that, either in the V3 channel or in one of the maintaining channels. So I hope that's been a helpful guide just to try and get you into the mentality of what these different files are. I really want to emphasize the sort of quick, easy first steps of get something done, get it out there, try and get some code review off other people. and then build on that over time. At the stage you're at, just getting a simple first pass that we can give some simple feedback to is a lot easier than doing something that in great depth that's got loads of sort of more fundamental mistakes in that we then have to do really in-depth code review on. That takes a lot more effort for both of us. So get an easy first pass, put it on there, let's have a look at it. We can easily comment on there, and then we can move forward. If you've got any questions, either ask them on this video below on YouTube, or post them into Slack, or feel free to open GitHub issues. Either none of those are any better or worse than the rest. As long as we find them, we can answer them. Thanks for working on V3. We're really excited to see how these things progress, how they expand. Really excited to, in the not too distant future, have a UI where you can start to see all of these things coming through. And do remember to go and check the research website out as well to get a feel for how the in-browser thing is going to work, how the test running is going to work. And that should hopefully get you a bit more excited about how this is all going to fit together as well. Thank you for watching.